Okay, so hello everyone, how are you guys? From today we'll be starting a very good solutions of Introduction to Electrodynamics by David J. Griffiths. I'll be doing all the questions or all the important ones and uploading on YouTube. So the book that I'll be following would be fourth edition of the Griffiths. Okay, so without wasting any time, let's just dive into it. So, at starting of the first chapter, most of the questions are very basic. So, I'll be just starting now from the gradient. So, from gradient, I expect you know almost the basic thing about what is a gradient, and how to find it. So, basically, to finding a gradient is termed as del dot t, where t is some function, or we can write it as del dot f, where f is some function, and we can just write it as del by del x f I cap plus del by del y f j cap plus del by del x f of z k cap, or the things or notations used in David J. Griffiths are del by del f x cap. Rather of using I cap, they have used x cap plus del by del y f y cap plus del f by del z z cap. Okay, I always get confused on this z thing, just a personal thing. So I'll be just starting from the questions after that, which are good ones or not so obvious ones. So the first question which I can find is, as I will be following the fourth edition, it's example. At least I wouldn't be solving the solved examples, or if I find to tell something important, I would also take those. Okay, so let's start. The example 1.3 states that to find the gradient of a function r equals to plus z square, the magnitude of position vector. Okay, so before I will be telling you much more things about specific this function and different ways you can find the gradient of this function. So first we'll be doing the most basic method for now, and after few more questions will be, so I would be telling you a much easier way or a much good way to solve this question. So we'll be just using the above formula. It's del dot r grad by grad x z square x cap. I would be just following the notations of Griffiths because few of you might get confused. Del by del y. Okay, so this is a very easy and but obvious to solve. We'll be just differentiating this function, so we'll be getting 1 by 2 root over z square from the first thing. We'll be also getting above 2x. Similarly, 2y, 2. Okay, so it is very but obvious. 2 gets cancelled, and majority of the things just pull out and are common. So x square plus y square plus z square, x cap, y cap plus z cap. Okay, so by noticing it, we can just write it as the above thing. Okay, so what's the above thing? By seeing that, we can tell that above thing is written r vector, and the bottom one written is mod r. So we can, where r equals to, where vector r precisely equals to x cap plus y cap plus z cap. So this is r vector by r, modulus of r, we can write this as modulus of r equals to r cap, the direction vector of r. Okay, so this was the very first method of solving it, and the most basic one to solve this problem, and where most of you would find the solution of this question online also. So now I'm telling you much fun way to understand this problem. I just name as method 2, and there are many methods also which I would be telling you, method 3 and method 4. So what's method 2? Just carefully see the r, it's x square plus y square plus z square. Okay, just think of it. What is it? Okay, by just our first inspection we can tell it is a modulus of some vector r, isn't it? So the vector r can be termed as x cap plus y cap plus z cap, and that's the pointing vector, or I shouldn't name it as the pointing vector, as it is some other thing which would we encounter in further chapters. We can just name it as the location vector of any point P on the coordinate system x, y, z. Okay, so let point P here, x, y, z on space. So the vector r which would you write would be this x cap, y cap plus z cap. Okay, the thing which you should keep in mind is always x cross y gives you z, x cross y gives you z. Okay, always keep it in mind that, because in many problems which I have shown online has some mistakes in this. They have just reversed x and y. So just keep that in mind, or else you won't get the solution sometimes. Okay, so back to the question, and this r vector shows the vector of a point P in space. Okay, this, and we'll be finding gradient of r. So what is the gradient of r? It is actually the derivative of r in 3-dimensional. So now, as I expect you to you have read Griffiths till the point of gradient and also what is written in gradient. So if I take a room, I would be taking examples from Griffith and some of mine also. It is in a room, if there is a temperature which changes in x, y and z. So the question is, at what rate does the temperature change in x direction, or what rate in y, or what rate in z? So simply by finding del r, which you would get here as x, here as r cap, means it signifies if the temperature vector you get is r vector, then the rate of change of temperature in x direction would be x, in y would be y, and z would be z. Just think of it and pause the video here and think about it. It's a really good thing to notice. So here, gradient of r, you are finding the gradient of r of a pointing vector of okay. So again I spoke one pointing vector, I shouldn't, of the position vector of point P. So you're finding gradient of r. So isn't it obvious that it would be r cap, a unit vector, as it is a position vector of a point P in space. So the rate would be r cap. Okay, so here is the second method, where just pause the video here again and try to think what I have just done here. So there are also other third method also which I can think of right now, but it contains a spherical coordinate system, so I won't do it now. After we solve problems of spherical coordinate system, I would get back there and back to this question and solve the third method for this question. Okay, so thank you for them and see you next time.